Okay, let me look now at the combination of resistances today. Earlier we have done about resistances, then we did about the Ohm's law, then we talk about the one more intrinsic property called resistivity. So now we'll try to analyze if we can manage resistances together. By adding two or more resistances we can get more resistance. Sometimes we have to make less resistance also. So today we will try to analyze how we can make a large resistance or how we can make a small resistance. So here the topic says the combination of resistances. Combination means you are joining two or more resistances together. So there are three possibilities. One, you join them in series, other is parallel, and third is mixed combination, means combination of both of these, right? So first let me talk about the series combination. In series combination, students, we join the resistances one after the other. Let's see how. We join the resistances like this. This is the first resistance, this is the second resistance, this is the third resistance. See, the one end of this resistance is joined to the battery, the other end is joined to the first end of the another resistance, and its other end is joined to the first end of the third resistance, and the last resistance is completing the circuit. This is the switch, we all know that now, and this is a closed circuit now. The current is flowing from positive to the negative terminal. Okay, there are a few basic things about the series combination. One basic thing is that in series the current remains same for all of them. The logic is very simple. The amount of charge which is flowing from here will go definitely from here also. That same charge will go from here, same charge will go from here, same charge will go from here. So the current will remain the same, but due to the difference in the resistances, the charge have to spend some energy to overcome this. So there will be a change in the voltage. So we call it voltage drop. Here the voltage drop will be V1, V2 and V3, and this total drop will be the energy supplied by this cell. So total sum of these V1, V2, V3 will be V. So I have made some point for summarizing this. Let I explain you that. First thing, the total resistance remain the same. It is sum of all of them. Mathematical sum means you are adding them like 1 plus 2 plus 3. N means any number of resistances you have. The total resistance is always greater than, suppose you are adding 2 plus 2, the answer will be 4, that is greater than 2. So it is very common. In series combination the current remains same. I explained you the potential difference is dropping each time. The logic I told you here. Now we should know how we got this formula here. So that is the part of derivation. Just consider this picture in your mind. This circuit diagram, will be using this for derivation. Here you see in the circuit diagram these terms were mentioned, R1, R2, R3, V1, V2, V3 respectively. That the current is I because it is common for all. By Ohm's law, at R1 V1 equal to IR1, V2 equal to IR2, and V equal to IR3. Let we have a combined circuit which have the total voltage V and total current I and total resistance R. So what can I get here? V equal to V1 plus V2 equal to V3 means the energy supplied by the battery will be the energy used by all the appliances. Law of conservation of energy. So I place the values. V, as we know, V equal to IR here. So if you put IR here, so I and I cancelled. So we are getting R equal to R1 plus R2 plus 3. So we can write it like this. So in series combination, total resistance is mathematical sum of the individual resistances, right? Let me try to use this formula for a numerical. Find the equivalent resistance of R1, R2. These are the two resistances joined together, 4 ohm and 3 ohm for example. So the total resistance would be sum of both of them 7 ohm. Quite easy. Let I enlarge my question. Now I have three resistances, 2 ohm, 3 ohm and 5 ohm. All are connected to a battery of 12 ohm. Okay, positive, negative. Now the question says to you, find in the given circuit, find the potential drop at each resistance and current in the circuit. So if we are talking about current in a circuit, so we must know what is the resistance of the circuit, because we know the total voltage 12, but we don't know total resistance. Now you see all are in series, so the total resistance will be the sum of all of them, that is 10. So voltage is 12, so I equal to V upon R, that is 1.2 ampere. Now this 1.2 ampere will be here, 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 everywhere. So if the current is 1.2 ampere, resistance is 2 ohm. By applying Ohm's law, I can get voltage here, I can get voltage here, I can get voltage here, like this. So V1 equal to IR1. So I is same. You see this one and this one. Only the value of R is changing in all situations. Once you place these values, we are getting the total voltages drops at each resistance, 2.4, 3.6 and 6, right? One important conclusion which you can draw, that is the law of conservation of energy, students. The total voltage, if you measure by the individual resistances, will be equal to the total voltage supplied by this cell. Here we see V1, V2, V3, the values are here 2.4, 3.6, 6.0. If you add all of them, you are getting how much? 12 volts, and see, it was a 12 volt. That's the crucial case of law of conservation of